Mr. Chairman, ladies and gentlemen, in addressing an audience of chemists, I must remind you that for us in the medical school, chemistry is an applied science. We are obliged to work with a test tube in the one hand and a frog, a mouse, a rat, or a rabbit in the other. Our field of work lies largely in the borderland between physics and chemistry and biological and medical science. I can only select a few examples from among many researches that have been carried on in the last 40 years by way of illustration of my statement of our great dependence in the field of biological research on chemical and physical science. One of the topics that I should like to present to you concerns what is called vividiffusion. You see before you an apparatus that brings out certain points in this field of vividiffusion. We have here a system of celloidin tubes attached to short glass ends at either end of this apparatus. Through these tubes, substances can be made to diffuse out of the bloodstream of a living animal. At this point, the apparatus is attached to the artery. The blood flows into the apparatus, up one tube and down another, and so through the whole system, and enters the body again at this point. Outside of these tubes, in this large apparatus, is contained a physiological salt mixture. This is in osmotic equilibrium with the blood, this mixture, and prevents the escape of salt from the body fluids. The red corpuscles of the blood and the large protein molecules remain in the bloodstream as it circulates in this apparatus. And only the diffusible crystalloidal substances, and some that are not crystalloids but consist of small molecules, escape through the celloidin tubes into the outer fluid. Please note that this apparatus is attached to a living animal, so that we have here a part of his blood circulating outside of the body, circulating in this apparatus in such a manner that it can give off the fusible constituents to the fluid outside of the tubes. In order to allow the blood to circulate in this way, in this apparatus, outside of the outside of the animal body, we must mix something with it that will prevent the blood from coagulating in these tubes. The substance that is mixed with the blood is allowed to enter the apparatus at this point. From this tube, this substance in solution meets the blood as it enters the apparatus. and prevents it from coagulating. It is a substance obtained from the upper part of the digestive tract of leeches. The leech, when he sucks blood from an animal or a human being, keeps the blood fluid. After a leech has gorged himself with blood, if you cut him open, you find that his stomach is filled with fluid blood. So in this apparatus, the blood remains entirely fluid, and the small amount of leach substance that is mixed with the blood is non-injurious to the animal. I came to devise this apparatus from the following viewpoint. I was speculating on the sad condition of persons in the terminal stages of chronic glomerulonephritis. These persons vomit continuously, they have severe headaches, their internal organs are gorged blood, they are often edematous, that is, have fluid accumulating in the limbs. As substances accumulate in the blood, because their kidneys can no longer excrete them, these persons become seriously ill, constant headaches, together with some of the symptoms that I have described, and finally, there is mental confusion, loss of consciousness, what we call coma, and they may die in this condition. Now it occurred to me that as long as the kidneys can no longer eliminate all of these substances from the body, which, when retained, cause this toxic state, I say it occurred to me that if in some way we could remove these toxic substances from the blood of these patients, they might be improved, at least for the time being. Our experiments had to be made with living animals. And the apparatus was attached in the way that I have pointed out, and further studies were made. In our experiments on living animals, we withdrew the outer fluid, which I call the physiological saline solution. That is a solution containing about 0.8% of sodium chloride in water. We withdrew, I say, this outer solution and subject it to analysis. This withdrawal is done every half hour, as in that time the outer solution has accumulated a sufficient quantity of diffusible substances that have passed through the colloidine tubes into the outer fluid from the blood. On analysis, it was shown that this outer solution had taken up 3 amino acids from the blood, sugar, organic acids, and many other constituents. If we had injected sodium salicylate into the blood of an animal, this was also found in the outer fluid, having escaped through the colloidine tubes with the other diffusible constituents. At this time, When this apparatus is working, the kidney itself sends out very little in the way of its ordinary secretion. That is to say, this apparatus has the advantage. The diffusible substances that are in the blood below the threshold value is necessary to stimulate the kidney. It is very effective then in comparison with the kidney itself. And any substances that we do not wish to lose in the blood can be retained in the blood if the concentration of that substance is made to be the same in the outer fluid as it is in the blood. This apparatus has been termed an artificial kidney. The term is not exactly correct. The more correct term, of course, is the one that I've used. It is a vivid diffusion apparatus. Because the kidney, after all, is a selective organ. That is to say, it selects this or that substance from the blood and passes it on into the urine. This apparatus passes out everything that is diffusible except the large protein molecules and the blood corpuscles, as I've said. Very interesting physiological, biochemical experiments were made in a series of researches that were carried on by myself and my associates, Drs. Roundtree, Marshall, and Turner. But I cannot take up all of those points in this brief presentation. I should like to add, however, that recently, or rather within the last 2 years, a modification of this vivid diffusion apparatus has been tested out on patients by Professor George Haas, the clinician at Gießen, Germany. He had patients that were badly off the last stages of glomerulonephritis. They could not rest. They had to sit up in bed. They suffered from constant headaches, vomiting, and all the symptoms that I alluded to before. After their blood had been purified in quantities of 400 cc at a time, there being 10 such purifications in all, these persons were greatly improved and temporarily benefited. Of course, you cannot hope to restore such people to health, to permanent health, because the kidneys are so far damaged that they cannot be repaired. But you can decidedly improve their condition, an improvement that extends over 5 or 6 days. The headaches vanished, the vomiting ceased, they could lie flat in bed again, they could sleep without hypnotics, and were improved, as I said, very much for 5 or 6 days. We ourselves were prevented from trying out this apparatus on human beings by the occurrence of the World War, when we could no longer import leeches for our investigations. Nowadays, however, we have a substitute for leech extract in the heparin, a substance obtained by Dr. Howell. This heparin prevents the blood from coagulating and is very suitable indeed for experiments on human beings. There are no doubt other instances where this substance could be used. For instance, in cases of mercuric chloride poisoning, when the kidneys are severely damaged and the patient is inevitably lost, there may possibly be a chance for recovery if it is applied in those cases for several days and the kidneys are given a chance to recover their function. That is merely thrown out by way of suggestion. I must leave this topic now to take up certain other subjects.